Alright, so we're going to deal with word equations today, which is sort of the beginning of the balancing of equations and stuff. Ashton, you look like you've got an earbud in. Am I right? No, not anymore. So we're on page 218 here, if you want to follow along in the book. We're going to talk about word equations today. You got your textbook today, Troy? No? Chad's textbook today? Want to open it up, page 218. Is it? You want to run and grab it? Go real quick. So on page 218, we're going to look at word equations today. Chemical reactions may involve sophisticated chemicals, as in the explosive reaction of dynamite, or simple household materials, as in the reaction of a bathroom cleaner with a stain. They may occur constantly, as in the growth of your body, or occasionally, as in the color of changing of color of leaves in the fall. How can you describe such a wide range of reactions? For convenience, chemists use a word equation. A word equation is one way of representing a chemical reaction. It tells you what reacts and what is produced. Word equations are an efficient way to describe chemical changes, to help chemists recognize patterns, and to predict the products of a chemical reaction. So what is a word equation? If you had to describe it in your own words, what would it be?
Describing something in a word.
Is that a good way to describe it?
I love that.
What are we talking about here? We're talking about chemical reactions, right? So it's just a way of what? Way of describing. It's up to you. Entirely up to you. It's a way of describing what? Okay, how about we say it's a way of describing a chemical reaction. I'll try to write it so you can read it. In words. Is that not really what it is? It's a way of describing a chemical reaction in words. Let me see if it'll recognize my handwriting. It's a way of describing chemical reaction in words. That's what it is. Do we care in a word equation how much stuff is produced? Like, do we care about that counting atom stuff? No, we don't. We just talk about what's the reactants and what the products are. Okay? So in the next paragraph there it says word equations are written in a particular format. The left side of a word equation lists the names of all the reactants, which are the substances present initially, and the right side lists the names of all the products, the substances present at the end. An arrow points from the reactants to the products. So the reactants is substances at the start. That's what you start with. Those are called the reactants. And Christian, what are the products? Well, the reactants are the substances at the start. What would you guess the products would be? Sorry? Substances at the end, exactly. Okay, so that's an important word that you would need to know. It might be a matching or a multiple choice or a fill in the blank on a test, right? But for sure, you need to know what the reactants are and what the products are. The reactants are always on the left, and the products are on the right. So it would look something like this. Reactants, and then you use an arrow. Products. That is a very simple, generic word equation. Reactants go to products. All right. If something oxidizes, what does that mean? Anybody know? What does it mean to oxidize something? Happens all the time. Rust, exactly. Oxidation is rust, right? Rust generally takes a long time, doesn't it, right? Reading in the book here, you know that rusting of iron is a slow process. It takes a car a long time to rust. Maybe less time if there's salt on the road. Hello? I do. He can come, yes. Okay. Nathan there, looking for anything else. Alrighty. So yeah, it takes a long time for a car to rust. However, when hot steel wool iron is plunged into a bottle of oxygen, a spectacular chemical reaction occurs. The reactants are iron and oxygen, and the product is iron 3 oxide. The word equation for this reaction is written as iron plus oxygen gives you iron 3 oxide. I'm just going to delete that one because I know I've got it somewhere else. Okay? Iron plus oxygen is iron 3 oxide. That is a word equation. Wouldn't you like to see what happens when you put iron and oxygen? Who would like to watch a car rust?
Sure. Take the rest off the toothpaste tape.
Can you really? How does that work, do you know? It's a chemical reaction though, right?
Yeah.
Toothpaste is basic, I think, right? Yeah. I'll check that out, I don't know. You can't take a lot.
Not a lot.
Yeah, just a little.
Yeah, we can get something and clean it.
Yeah, like clean it out.
Yeah.
Any special kind of toothpaste? Yeah? Okay, let's just get this link going here. When I write the word equation, there are no formulas. I don't say like 2 molecules of iron and oxygen gas. Remember, oxygen gas is O2. I don't worry about that. I just write the name of it. That's all I do. Okay? Wrong side. Okay, what's the next one? The reaction that occurs when a coil of copper wire is placed in a beaker of color silver nitrate solution shown in figure 2. And this one I can actually do. It's sort of one of those overnight things. So I'm going to get it set up. Okay, so copper and silver nitrate would be the word equation. In this case here, what are the products? Sorry, the reactants. What are the reactants? What are the reactants? The things you start with. Copper and silver nitrate. Here's what it looks like. Leighton, I need you to put the phone away. It's silver nitrate, Matt. It's not methanol or nothing. Silver nitrate. Okay, so that's copper plus silver nitrate, silver plus copper nitrate. What are the reactants here? Troy, what are the reactants? I'm giving you a very strong hint. Copper and silver nitrate. Where are the products? Over there, right? The products are silver and copper nitrate. We will get to where we have to write the formula for this happening. We're now just worried about the word equation. Okay? The next one. Zinc plus hydrochloric acid. Zinc plus hydrochloric acid. Let's see what happens. What do you think? Anybody know what hydrochloric acid, what the formula is? There's the zinc. Zinc is a metal. What does it appear to be producing?
Gas.
Some kind of gas. What gas do you think it's producing?
Carbon.
I'll give you the formula for it right away, and then I'll ask you that question. There's a big bubble. It's clearly producing some kind of gas.
Oh, what you call that? Aspartame.
Aspartame? Like sugar?
Isn't that what's in the drinks and all gassy?
Yeah, that's carbon dioxide that makes it gassy. Aspartame is the sweetener. That's bubbling good now. What's going to happen to the actual zinc, do you think? Like, is there going to be the same amount of zinc at the end? Well, now they're testing for hydrogen gas. Okay, so what was produced? We've got zinc plus hydrochloric acid. And what is produced in the book tells us that it's hydrogen and zinc chloride. So what was the gas that was being produced? Hydrogen gas, H2. Is hydrogen gas flammable?
Yes.
Have you seen the video of the Hindenburg?
Yeah.
What was it full of? Hydrogen gas. Is it flammable? Yes, extremely flammable. Why did it do that little pop thing at the end?
So broken.
No, it was basically, it exploded, but is there like a lot of hydrogen gas being produced? Just a tiny little bit, right? So basically it exploded, it burned up, but it burned up so fast, that was the end of it, and that was just it, right? Obviously the Hindenburg was huge. When it caught on fire, it took a long time to burn up. How come the Germans used hydrogen gas if they knew it was so flammable?
It's cheap and easier to produce.
Yes, and the political climate of the era, they would not sell helium to the Germans. They couldn't produce their own, and so that's why they used hydrogen, and that's why the Hindenburg blew up. They used helium gas. Is helium flammable?
No.
It's one of those noble gases, right? So inert kind of thing. Okay. I think we've done all this. You know what? Let's just skip right to let's go right here, okay? So on page 219, there's only like 3 questions there, 2, 3, and 4. All you have to do is have a look at them and then tell me what the word equation is, or the reactants in the product. In question number 3, you have to actually write the word equation, so you're going to have to look up some of those things. And then number 4, write word equations to represent the following reactions. So we were just writing word equations here. Okay, a little bit of practice. Then we'll check these in a few minutes.
Are you going to call it?
All right, well, let's have a look here. So number 2, examine the following word equation, which is propane plus oxygen. So if you're a fan of Hank Hill and King of the Hill, you'll know that propane and propane accessories are important. So we've got propane plus oxygen. And let me squeeze this over a little bit. Gives us carbon dioxide plus water. So when you are grilling your steaks and you're burning propane, you're combining it with oxygen. Where does the oxygen come from?
There.
The air. And what is given off? Carbon dioxide, which is completely harmless. We all give it off when we breathe it out. And water. And the water is in the form of a gas, exactly, right? So all you have to do here is list all the reactants. Where are the reactants? Okay, Leighton, I need you to watch now. Where are the reactants? No. Where are they on the equation? Left or right? Left. Where are the products?
Right.
On the right, carbon dioxide and water. Thank you, sir. Okay, so that's pretty easy, right? Those are the reactants products. What is the purpose of the arrow on the word equation? The arrow shows the result, or what the process, right? What happens?
Before and after.
The before and after. Very good. Awesome. Okay, I'll come back to the balancing equation. Okay, so I'm guessing number 3 was kind of hard, right? Am I right? Didn't even get that far. Write word equations for the following reactions. CaCl2. Now, we really didn't go through this, but you should be able to do that from the last unit. CaCl2 would be what? Yes, calcium chloride. That's good, chats. And then the next one is Na2SO4. Do you know what Na2 is? Sodium. Now, how do we find out what SO4 is? We didn't talk about polyatomic ions before, so I'm going to have to find that chart for you. But there should be a whole list of them on page 196. Flip to page 196. Flip to page 196. Flip to page 196. Polyatomic ions. So we're talking here about SO4, I think, right? SO4 is at the bottom there. SO4 is known as what? Sulfate. SO4 is known as sulfate. So it's sodium sulfate. And it produces CaSO4. Well, what Ca, again, is going to be? Calcium, we're still on page 219, but we're flipping back and forth.
Okay, what page, Sean?
We're back to page 219, that's where the question is. And it's CaSO4. So what's the SO4? Sulfate. We've already got that. Hello, Mr. Jack. So calcium sulfate. And what's the other one that's produced there on page 219? Okay, seriously, you guys. I know. It's driving me nuts. Okay, I just need you to listen. That's all I need. Do you know what page we're on?
Way to go. Yeah, 19.
Thank you. What question number are we doing?
3.
Number 3. We've got CaSO4, and the other one that's produced is, it says it right there. What does it say, Kent?
Where?
Page 219, number 3, part A at the end. Without putting my finger on it, I can't be more specific. NaCl, very good. And what is NaCl? Na is sodium, and Cl is chloride. There's your word equation. Thing. I'm going to have to make the solution, and I'll show it to you tomorrow. Okay? I'm going to show you that reaction when I get there. If I ever get there, if we could just do 3B, then we could get there. Again, page 219, number 3, part B, BaCO3. Let's write it out. BaCO3. And the next one is, reacts when heated to produce BaO and CO2. It reacts when heated. Is it reacting with anything? Ashlyn, what page are we on? Page 219. Question 3, part B. Stay with me, please. BaCO3 is heated. Is it reacting with anything? And the answer to that is no. It's not reacting with anything. What are the reactants? BaCO3. The products, BaO and CO2. You have to write the word equation. All you got to do is turn this into words. What's Ba? Periodic table? Barium? What's CO3? CO3 is one of those things that we don't know. It's not an element. You got to go back, put your finger in page 219, and go back to that list of polyatomic ions that I showed you. Go back to page 196. Go back to page 196, and we're looking for CO3, and it's carbonate. Exactly. Carbonate. Barium carbonate. Okay. BaO. This is the products here. BaO is going to be what? Barium. Just the O is going to be what, Christian? Oxide. Remember? We always end in "ide." Oxide. CO2. I hope you know it. You're producing it right now. Carbon dioxide. Easy stuff. Easy, easy, easy. I know it's not exciting. Not at all. Okay. Yeah, thanks. I think we'll leave the last one out. Clearly we're not getting very far here.
Yeah, no.